Hello, today we're going to do this integral from 0 to 2 pi of x times sine x divided by 1 plus cosine x squared. So it's not an easy integral. Most substitutions don't really work, don't really help us in any way. So what can we do here? Mostly this x is going to be annoying, and we'll see how we can get rid of that in a moment. So the substitution that we're going to start off with is going to be x is equal to pi minus u, which means by just switching some things around that u equals pi minus x, which also means that dx is equal to minus du. So all pretty trivial. So let's see what this gives us. So first of all, when we plug x equals 0 in, let's say, this right here, we're going to get so pi, and then let's see, so the integral from pi to 0, pi minus u times sine of pi minus u divided by 1 plus cosine of pi minus u squared minus 1 du. Now let's see quickly. First of all, we've got these ugly bounds in the wrong order, so we can fix that using this minus 1. So we're going to get the integral from 0 to 2 pi of pi minus u times sine of pi minus u over 1 plus cosine pi minus u squared. So how can we solve this? The first thing we're going to look at is we're going to look at these trigonometric functions with pi minus u. We can use some identities here. Now maybe if you don't really know these from scratch, we can just look at them graphically, and let's just see if we've got this angle theta, and we've got pi minus theta. Well, sine is just going to be equal because we've got this straight line here. And then secondly, we can see that the cosine is going to be opposite because of this, just the opposite side of our axis. So that's going to give us the integral from 0 to 2 pi of pi minus u times sine of u over 1 plus cosine. Cosine pi minus u was going to be negative cosine u, but that doesn't really matter because of the square, so we're going to get cosine of u squared du. Now maybe just to clean things up, we can change u for x again, so that's just a completely trivial substitution, just u equals x, and we can get to the same variable again. So now you might be able to see some massive similarities between these integrals. And let's just see if we call this I. What can we do with this? So we can split this part up into two integrals. So let's do that. So that's going to be equal to the integral from 0 to pi of pi times sine x divided by 1 plus cosine x squared dx minus the integral from 0 to pi of x times sine x over 1 plus cosine x squared dx. Now again, notice that this second integral here is just going to be I, so we're going to get minus I. Now maybe recall that this was all equal to I, so we're going to get this equation for I, and we can see that 2I is going to be equal to this next integral. So we now need to solve this integral over here. And as I said in the beginning, this isn't too tough. You again have to look at the right substitution here to go through this quickly. Let's see how we can do this. So maybe cosine x is going to be equal to, let's say, u. Cosine x is equal to u. That means minus sine x dx is equal to du. Let's see what that does to our bounds. So we're going to get, let's see, when you plug 0 into cosine x, that's going to give us 1 and minus 1 for pi. Then we're going to get minus sine x dx is du. So that means that if we put this pi in front, we're going to get minus 1 times du for that part, and then 1 plus u squared. Now next up, again, we can use this minus 1 to switch these bounds so that they're not as ugly anymore. Now this integral is also a standard integral, which you might need to know to do a lot of pretty nice integrals. So let's see what this gives us. That's going to be pi times the arctan of u evaluated from minus 1 to 1. Now maybe recall that the tangent of pi over 4 is equal to 1. So that means that the tangent of minus pi over 4 is going to be equal to minus 1. And so we can say that this is equal to pi times pi over 4 minus minus, which is going to give us plus pi over 4, which is going to be equal to pi squared over 2, which means that our integral I, which was the integral from 0 to pi of x times sine x over 1 plus cosine x squared dx was equal to pi squared over 4. So, nice result. We've got this pi squared, which is kind of uncommon to see unless you're dealing with some kind of Basel problem, but it doesn't matter. We've got this integral finished up by using this really nice and well-known substitution of pi minus u, or just basically switching these bounds and then just bringing them back to normal. So that's pretty common, nice trick to know. Hope you enjoyed this video. Pretty simple integral. Till next time, thank you so much for watching.